let's give this a go. We have Chapter 5, Lesson 2, Day 3, Real World Problems with Rates and Units. Extra practice, textbook page 258, 260, numbers 4 through 8. So, here we go. Looks like information, if we just scan through, is presented either in graphs or tables. And this should be okay, because I think it's just another way of organizing and making sense of information. So, question number 1, the table shows the charges for renting a boat. Let me turn the microphone a little bit better. So the table shows the charges for renting a boat. Mr. Cooper rents the boat for 9 hours. How much does he pay in total? All right. So Mr. Cooper going on a sunset cruise. So Mr. Cooper pays blank, and these are dollars. Okay. So 9 hours, and it looks like here the first 4 hours are $1,800, but then after that there's $500 per hour. So I think I'm going to try to do a bar model just to further make sense of this. So we know that I'm going to do one big bar. So this whole total is going to be 9 hours. And in here, it's according to that table, the first 4 hours. So let's make this into 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these first 4 hours are $1,800. So 1, 2, 3, 4 have a value of $1,800. Then each additional hour is $500. So that means all of these blue ones are $500 each. And so in order for us to find the total cost for this, it looks like we have to do $500 times, there's 5 of those units or 5 of those hours. So we know 5 times 5 is 25, times 10 times 10 is 2,500. So for these hours, he is going to do 1,800, or he will have to pay that much, which is $4,300. Awesome. Let me quick scroll. Check. Great. We are good to go. So the table shows the rates for renting cars at another car company. How much does it cost to rent a car for 3 weekdays? So that's going to be really important, that little detail of weekdays. So it looks like this weekend information, I'm going to just cross out because we don't need that for this first problem. We'll need that for B though, so I'll probably end up going back and digging that out again. So again, I'm going to do our bar model because that helps me visualize this. We know we have 3 days total. 1, 2, and 3. The first day has a value of $75, and then every additional weekday is $60. So that means we have 75 plus 60 times 2, or 75 plus 120, which is $195. So it costs $195. Let's check. Awesome. We're good to go. How much does it cost to rent a car on Wednesday and then keep it for an entire week? So I'm going to go back and get that information. So we're picking it up on Wednesday, and then we know a week is 7 days. So 1, 2, 3, 4, 5, 6. This is Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday. So the first day is $75, and then every additional weekday is $60. So that's 60, that's 60. And the weekends are 80. And then weekdays go back to being 60 again. So when we look at this, it looks like we have 75 for Wednesday, plus, let's count the rest of our weekdays. We have 60 times 1, 2, 3, 4, plus our weekends, which is 80 times 2. So I'm going to write that out all in one expression because why not? We know order of operations, so let's do it. 75 plus 60 times 4 is 240, plus 80 times 2 is 160. So I'm going to combine these two because it's going to be 400. I know 60 plus 40 is 100 plus the rest of that. So 75 plus 400 is 475. So it will cost $475. Awesome. So because he's returning it on Wednesday, he's not going to pay for that Wednesday. So for an entire week, it will cost $475. Cool. Ooh, so now we have some graph information. So a machine dyes an equal number of same-size shirts every hour. So we have a rate of shirts per hour. Shirts per hour. How many shirts does, okay, what is the unit rate? So if this here is over 6 hours, it looks like we have points. When we're reading these graphs, we want to look and see where does that line cross exactly where like one of the hour markers is and then one of the number of shirts. So looks like we have 3 choices for what we could work with, and because of what we know about proportional relationships, it's going to be the same. Our answer will be the same no matter what. So if we know, and I could set up a rate bar for this, or I could set up a table, but these are shirts per hour, and we know that we're looking for the unit rate, which would be 1 hour, and I'm going to go with, let's start with 6. Yes, 6. Oops, 6 shirts. 6 hours, you can do 450 shirts. So that means if we divide by 6, that will get us our unit rate. So 450 divided by 6, I'm thinking of that like a 420 and a 30, because that is 70 and that is 5. So they can do 75 shirts per hour. You know, just to be sure, I am going to make a quick table to see my calculation if this is accurate. Shirts per hour. And so let's start out with what we know here. For 2, if we go up and then over is, so 2 shirts, nope, 150 shirts in 2 hours, or 300 shirts in 4 hours. So what we know about like proportional relationships and ratios is that if we multiply that by 2, we have twice as long, so we're going to be able to do twice as many shirts. And if we want, we could add these, so 2 plus 4 is 6, so then we would need to add that number of shirts. So here, this does seem to track with this does seem to match all of our calculations. When we organize the information from this chart into a table, it does look like everything seems to match up. And what is nice about knowing the calculations for that unit rate is that we can guess that this point here for 1 hour is about 75 because it's between 50 and 100. But the only points that we know for certain are the ones where our line here that I'm going to highlight in yellow, where that line crosses those grid marks perfectly. So that's pretty good. Now, how long does the machine take to dye for 375 shirts? So again, we could check and see. 375 will be about here. So it looks like it should be about 5 if our math calculations are correct. Again, we can't be certain because this graph isn't quite accurate enough. It doesn't have enough grid lines on it. So let's see. We have a couple options. If we want, we could start with our unit rate. And I'm going to do our unit bar for this, or our unit line for this. Again, shirts per hour. We know 75 shirts in 1 hour, and we want to know 375. So we're multiplying by something. So I'm going to do 375. Ooh, I know that's a 300 and a 75. And I'm picking this 300 because I'm also thinking in my brain, a 300 is a 150 plus a 150. And each of these 150s is a 75. So there's this divided by 75. There's actually 4 of them in there because that 300 is 2 150s, and each 150 is a 75. So that's seems pretty reasonable for me to get through. And so it does look like that we would have to, that there are, I don't know, 5 times 5. And that would get us our answer here of it would take 5 hours, which, you know what, it did match what we looked at on our graph. So pretty awesome. I think these types of problems can be a little bit, not intimidating at first, but the information is provided in a way that just takes a moment that you have to sit with, and then you can definitely figure it out.